500 episodes of the Carolina Weather Group and counting. This is going to be an episode like you've never seen before. Welcome to IBHS in Chester County, South Carolina. Buckle up.
You can say this episode is pretty hot.
This episode is
Pretty lit.
It's the hottest episode.
Yeah, it is lit.
Welcome to a special edition of the Carolina Weather Group. We are here in person in Chester County, South Carolina, celebrating 500 episodes of the Carolina Weather Group and counting. We are at the Insurance Institute of Business and Home Safety, and coming up in this special edition, we're going to have fire, we're going to have hail, and we're going to have some of our favorite Carolina Weather Group memories. We've got Jared Smith, we've got Dan Whitaker, Candace Jordan, producer Tim Pounds is here for the special day that we have in store for you, and our special thanks to IBHS for opening up their doors. But as we've been talking, the big science lab behind us, the Grand Lab here at IBHS, they are getting ready for a fire demonstration. Looking out at the monitors, I see them getting all set. I think we're going to watch some scientists light some things on fire. Welcome back. We have stepped outside because we are about to watch a wildfire demonstration. I don't think I've ever seen anything quite like this before.
No.
Jared's just like, no. The purpose of this experiment is to understand fire spread. And so they have built here at IBHS some auxiliary housing units that might mirror what you have here in other parts of the country. And they're going to see exactly how fast and how far a fire might spread given certain conditions, such as wind. All right, so they've just lit those pallets that they are using as the source of the fire. So the purpose of this demonstration is to see how fast that fire spreads to this first dwelling. They are using the big fans inside the IBHS lab, the ones that we've seen during hurricane demonstrations, and they are using that to pump air out of the chamber to push and simulate a wind flow from that source. And the West Coast, infamous for their fire season, but we have a fire season here, Candace, too, in the Carolinas, so everything they learn here will be applicable.
Yeah, we get the fires, especially up towards the mountains. Remember the one up towards like Pigeon Forge, Gatlinburg, covered the one on Pilot Mountain before, so there's been quite a few here in the Carolinas, though I would say probably not to the extent of the California seasons, but definitely applicable here. Anybody else see? Anybody see a little eddy there? Little vortice?
Murray here is the managing director of research. Thanks for having us today. We've now seen that the pallets being used to kind of start the fire are now fairly engulfed. What is it that you guys are looking at here as we wait for this to spread?
Sure. So what we're looking at is we're looking at how this ignites the actual structure and how the fire actually progresses through the actual structure from this external ignition scenario. And we're looking at how different ignition mechanisms can change the exposure that downstream building will see.
What are some of the weather factors that are being simulated here to help learn about how things would work in the real world?
Sure. I think the number one is a wind-driven fire spread. So our fans allow us to look at different wind speeds to really mimic what fires would experience in the real world rather than just an ambient condition where the wind isn't blowing. And how does that actually bend over the flames and change the amount of radiant heat and direct flame contact that structure would experience?
What are you seeing as you're staring at this experiment? I see lots of fire, but I
see the exact same thing you do. I'm waiting for the exciting start to happen. So once we ignite that structure, either we ignite the wall material, or we actually might even ignite under the eaves there, and the fire might actually start into the attic space.
Yeah, it looks already like we've got the heat. You can see it coming off the roof there.
Yeah, that's right. You can kind of start seeing that you have a little bit of gassing on that fascia board there. And now we have the fire really going. You can't even see it.
I can feel it. All right, I'm going to let you concentrate, Murray, but thank you.
Yeah, thank you.
I'm also going to go check to make sure our cameras are not melting. They've got cameras positioned inside this experiment. We can see some of those angles right now.
Yeah, you can definitely feel the heat here. There goes the house. You can see the corner of the house here has ignited.
We've just noticed that the fire has spread and very quickly engulfed the whole front side of the house. Siding is actually coming off the front of this house here. You can already see how quickly the front of the home has been charred as more siding continues to pop off the front. So just inside these big hangar doors, that is the lab that IBHS has used. You've seen the footage before. That's where they build the homes, that they test the hurricane, they test hail, they test indoor and outdoor sustainability of construction materials to help us build smarter homes. Well, they are opening those doors using their wind-generating fans to push air out onto these ADUs. These are auxiliary housing developments. They might be ones that people have in their backyard, whether for friends, relatives, or renting them out. And that's what they're testing here with CALTECH and CAL FIRE. And we can just hear now, the winds are cranking up. The fans are cranking up. The fire is raging. They were not kidding when they said it was going to get very hot right here. Dan and I both going in, I think, to pull our cameras back. I like to go home with my camera at the end of the day. Woo! Everyone here has just taken huge steps back because as those fans cranked up, so did the fire. Candace, they weren't kidding when they said it was going to get very hot.
Yes, like my forehead is burning right now. Like it is warm. Oh, my eyes are watering. Ooh, my eyes are watering.
So they are doing this experiment like all the experiments they do here at IBHS with safety in mind. They've got the Richburg Fire Department standing by in case any part of this experiment got out of control. So far, it has managed to stay contained to the structures being used inside this experiment. My phone now telling me, this is no joke, the device is too hot and the quality of my recording may be diminished as the phone's trying to cool itself down.
Wow, that's impressive.
Back even more. My phone is overheating from the fire.
Is that wild?
Jared, I can only imagine what this thick black smoke looks like to anybody who might be in the area, but now we've gotten to the part where the fans are ripping, the first structure is on fire, and we're watching to see what happens to that second structure.
Yep. Exactly. And I'll tell you, James, you know, I mean, all of our phones are throttling right now because it's so warm. It is very warm back here. They're starting to fire up the water a little bit because I think it's getting close to the second structure. And they're going to extinguish when it gets to the second structure. I'm glad that we have places like this to test things like this to help keep people safe.
And what a remarkable place to have here in the Carolinas, a one-of-its-kind lab, because this is spectacular to watch, but this is full-scale science that's happening.
Yes, absolutely, absolutely. And this is the kind of stuff, you know, I have a lot of family in California, and this is the kind of stuff that helps keep them safe during fire season. So it's amazing to see this up close and a little toasty.
Jared, as you mentioned, that they are intentionally for this experiment burning down this first structure.
Yes.
There is a second structure near it. The purpose of that experiment is to see how fast, how quickly the fire might spread from one building to the next, but they're not going to burn that one down.
Correct.
As we've been standing here, the whole front roof is now disintegrated and caved in.
Yeah. This is what they call fully involved. And the winds are about 35 miles an hour. And what we're seeing is, we're seeing on the second structure, we're seeing, shingles are melting, the sealant is melting, and so any little bit of wind at that point is going to kick those shingles up. It is really, really something here. And again, 35 mile an hour, that's it kind of tells you, when you have that red flag warning, when you have those, this started from a couple pallets, right? And so, so when they issue that fire weather warning for, gusty winds and low humidity, this is why.
And I think that was one thing that was so impressive. They had lit the pallets, they were going for a little bit, but really when they kicked up those winds, that's when the heat just blasted us. Like you could tell, like it went from, this level all the way up to this level. Like it was amazing to see that difference.
just as we were standing here continuing to watch the fire burn, we watched this one section of the first structure fall off and blow in the wind and just scoot to the base of the second structure. So we are watching anxiously to see if that will be the moment that the second structure catches fire, thanks to the wind carrying that from one building to the next. You can actually see a second piece now blowing in between the two structures. Again, the fans here at IBHS cranking out of their wind tunnel at about 35 miles an hour to simulate what is a very real and very scary experience during wildfire season in so much of the country.
Like, I'm surprised that first initial blast didn't immediately get that second home. Like, it's taken it longer than I expected.
Which would be really good news if you owned the second structure.
Yes. Yeah. I mean, that's what they're testing for right now. I mean, they're testing to see, like, how far apart do these buildings need to be, to hopefully translate into safety. Right there below that corner door there, it just looks like a firework. Like, that little piece of debris that went over there that was on fire is still just going at it. It almost reminds me of like a firework at the bottom of the house.
Yeah, it's relatively small compared to everything else, but big enough that it could be a problem. I'm also watching the siding nearest us on the first structure. Looks like it has reached the point that it is not going to be able to maintain its integrity much longer.
I think from a building dynamics, it makes sense that the roof was the first thing to go. You're kind of left right now with the exterior walls and then kind of some internal like beams, but those are starting to give way.
The other thing I'm noticing, Candace, if you look at the front of the structure nearest the wind tunnel, you can actually see how the heat and the smoke is being carried up at an angle. It reminds me of like when you see a car in a wind tunnel and they're testing the aerodynamics of it. You can see that happening here with the fire structure.
Yeah, you can see it right there. It's almost like the fire and the smoke is creating that aerodynamic look for you. Oh, that one like piece of roofing there, I think it's gonna go anytime.
Yeah, that bottom corner still has, and this could be it here. This could be the moment. We're continuing to get hot pieces from the first structure right there at the base of the second unit. The fire department's standing by because we are going to put the second structure out. We're not going to burn the second structure, but we are trying to see how quickly it takes to start an ignition on that second structure. Marianne, you have graciously opened your doors to us. Let's watch these real world scale experiments that you guys do here. In terms of the IBHS mission, what do these real-world experiments provide scientifically?
Yeah, I mean, it's a cool day at work when you get to see this kind of thing, but it is real science at work. And so what we're watching today is one of our laboratory experiments that we will couple with in the field. When there's a post-disaster or a fire, we may send a team out to look and see what are we seeing that happens in a real fire. Do we see the same thing replicated in the lab? And so it's have a part of our work that does involve trying to inform building codes. Of course, that's your work in the future. So we've got that, and that's important work that we do from what we see in our research. But we also put together guidance, ready guides. We have a wildfire ready guide that's available on our website at ibhs.org that people can get their hands on. They can also look at wildfireprepared.org and see what they can start to do in their own home.
Yeah, because while in the real world, unfortunate situations like this happen, doing some of them in the lab might help head off, I would imagine, some instances in the future where if building codes could help guide safety.
That's right, absolutely. I mean, everything we do has purpose, and it's very meaningful, and our mission is definitely to try to reduce the damage.
All right, so it's been somewhere between 30 to 45 minutes now. The second structure has not yet caught fire, which is good news for the hypothetical homeowner of that second structure. But the heat has been intense.
Yeah, the heat's been intense, and there's still damage to the other home, too. There's some shingle damage. There's, we could see the windows yet go out on it. It's still very, very hot. But it could be worse.
But for us, our tour of IBHS is on the move, and we're gonna go from fire to ice and head inside their hail lab.
All right, so we've moved from the fire and now we've gone into the chill zone and we're talking all about hail. We've got Jake here with IBHS, and walk us through what all we're seeing in here.
Everything you see in this lab is born of a need to represent the hazard that we face, which is hail, right? So there are current test methods that are in place that measure impact resistance of different materials to hailstones, but they don't really represent the hazard. And so everything you see in here is a result of the need to represent that hazard and how it does damage to our building material. And so in order to understand what characteristics we need to replicate of hail, we have to go measure those characteristics. And so we go out into the field and we take three-dimensional measurements of hail, we weigh the hailstones, and then we get their compressive strengths. And so how hard are these hailstones? Because we know that stones of different hardness will do different types of damage. I can actually show you some of that equipment that we use in the field. Probably the most fun one to use is this guy right here. It's a hailstone crusher. And we really needed to find a way that this could be a mobile unit because we're doing this out of the back of a van in the field, right? We're storm chasing. Basically all it is, it's a construction clamp, and then it has a single axis load cell mounted to it. And so you put the stone in between these two plastic.
So have you noticed any patterns, like the larger the stone, the higher the number of strength, or is it kind of variable?
That's a great question. It is variable and it doesn't depend on the size of the stone. I've actually seen that smaller stones tend to have higher compressive strength than larger stones. Now remember, we divide it by the cross-sectional area, so it's not a function of size, it's a function of the material properties. You guys can actually crush some stones if you'd like. I can grab some stones for you.
I think we most definitely need to do that.
And if all of you want to crush, we have more stones too. But
All right, Jared, go for it.
all right, Jared.
All right. In 1, 2, 3.
Yeah.
All right.
Phone.
Okay, on my phone.
One more.
Just a clean break.
All right, you ready? I'm excited.
All right.
Ah!
That was a good crush.
Okay, we're locked and loaded.
That was the hardest one so far. You got up to 250.
Cool.
So James, the number to beat is about 250 pounds.
250 with how hard I squeeze?
Are you ready?
All right. Yeah, 3, 2, 1.
Keep squeezing. Keep squeezing.
Squeeze it again, like let it off.
Let it go and squeeze again. There you go.
Hey, looks like he got to about 175, 170-ish.
I was afraid that I was gonna be the first one not to break the hail.
We've actually found that hail doesn't recycle in the updraft.
Oh, okay.
It takes one pass through, and then it grows on that. It grows on that path, and then it. So the freeze time, the freeze duration is rather a measure of basically how the residence time of that hailstone in the hail growth zone, which is obviously where the hail grows in the storm, between -10 and -30 degrees Celsius. Found is that a longer residence time generally equates to a higher compressive strength. And so the longer that ice can sit in that freezing air, the longer it has for those ice bonds to kind of strengthen.
As you were talking, Jake, I was noticing behind you on the wire shelf, 2015 aging farm fire, you know, different ages of different material, and we saw up front where you guys have that farm,
Right.
where you have all that material. Is that to then come in here and do experiments with the hail to see how different roofs of different ages hold up?
Absolutely, yeah, and in fact, we just finished impacting some 10-year panels. And the material, the asphalt material at that point is so degraded that it actually scours some of that mat away and you can see through the shingle. And so you're losing so many granules and so much of that asphalt material that your shingle is basically ineffective if you get a hailstorm. The water is going through the shingle.
My roof's about 10 years old. I hope my wife is not watching right now.
Yeah. We're trying to solve that problem for you here, but it's a long road. It's a marathon. It's not a sprint, right?
And to show us how they do those hail impact tests, they loaded up their hail cannons for us to fire in their lab.
In 3, 2, 1.
All right.
That was 30.9, yeah.
30 per second. I shot the hail cannon. Yes. Yeah.
Yeah, it's about half the speed that you want it, so we can get you a better impact. So one thing that you know, if that was to spec, the stone didn't shatter, right? And so a stone that's to spec that doesn't shatter is called a hard bounce impact. And then we have 2 other modes of impact. There's the hard shatter impact and the soft shatter impact. And hard shatter impact is what it sounds like. It hits hard and it shatters. Soft shatter leaves residue on the material. And so you actually see like a snow coning effect. And that's really like a visualization of when that hailstone hits. There's a lot of lateral motion when that hailstone compresses. What that lateral motion does is it shears some of those granules off. Current test methods don't capture that damage mode. Our test method does capture that damage mode.
Gonna shoot the hail out of this. 3, 2, 1.
So that one was 52.9 miles per hour.
That's better.
That was a lot better.
52.9.
So right now, there isn't much to say in terms of damage. There's some denting here, and looks like a little bit of granule loss. But in general, we see that these newer products perform pretty well. It's when they start aging that we actually start to see a rapid decrease in performance. So even like out to a year, between 1 and 5 years, the performance just tanks. So we're seeing a lot of that.
I'm gonna be buying a roof when I get home, I think. All right, here we go. We've moved over to the other gun and another piece of roofing. Safety is off. Firing in 3, 2, 1. Whoa!
Hail, yeah.
That was a big one. Yeah, that was a good one. Oh my gosh.
And
Yeah. Thank you.
I mean, there's a reason why the plastic goes all the way around.
Right?
Because that was coming
It
right
came
back
right
at us.
back.
And it was pretty fast.
Thank you.
Thank you.
I'm gonna hold on to that instant replay.
Yeah.
All right.
All right.
Are you ready?
I'm as ready as I'll ever be.
You think you can do it?
I think I'm going to have a hail of a good time.
You have a hype up routine?
You know, we're just going to stretch and,
Doing this. Just, it can be vertical, that's fine. This is just for personal purposes. Yeah, we're going to...
All right, safety on. 3, 2, 1, fire.
No shatter.
No shatter. That's crazy.
Shattered on the second bounce.
That's crazy.
okay. 3, 2, 1.
That one was 87 miles per hour. Got a good blink out of that one too.
That would come up from the
So you get a sticker?
Thank you.
So you guys all had a chance to fire the hail gun, right? Yes. All right, so you might be asking yourself the question, what do we do with all this information after we fire these hail cannons, after we hit these panels with the hail? And so we'll actually take these samples that we impacted and we'll use machine vision to analyze the damage on those samples, right? And then we can rank the performance of products. This is a hail impact rating sheet. This is from, I believe this is the 2023, yep. And so we'll put this out into the market. So if you're just a everyday home buyer or a homeowner and you need to understand the relative performance of different roofing products, you can go online and search for this impact rating list.
Where to begin?
I don't know where to begin after that. What an incredible opportunity IBHS has presented us to see their real-world science experiments. Jared, I'm going to start with you for your reaction.
You know, I think the big takeaway from this is that this is science that helps people. This is science that saves lives. It's really cool to see it in action and really warm when it's simulating a wildfire.
Incredibly warm.
Yeah. But it's just, you know, we've got really passionate people here. It's just a really cool facility. And this is all the stuff that we take for granted every day. Why do things get safer? Because they do things like this.
Tim?
I mean, I was just shocked that something like this existed. And I'm sure there's fans out there watching this too. It's like, wow, this is such a unique opportunity, a unique thing. But we see the importance of it too as we're building stronger and getting better materials for this sort of stuff. So,
Candace, you've probably walked away with all sorts of goodies to bring back to the museum.
Oh, I'm so excited. It's so cool. Like, just like Tim was saying, like, getting to like shoot the hail cannon. So cool. But then also like tying it back to they're trying to save property and lives, and how does this size hailstone with this kind of strength impact a car, a roof, different things. So very cool, very cool.
And Dan, I think you've made some new best friends.
Yeah. I'm just gonna move in here, but see the state-of-the-art technology combined with the research involving storms and different types of things like that is truly fascinating. These industries can be difficult to make changes to, even if you have the science. There is a lot of lobbying and political consequences that come to all of this, and to see them hitting that straight on and actually trying to continue on with those changes is truly fascinating.
Incredible, incredible stuff. I'm making a game time decision. These guys don't even know it yet. We've got so much more we still want to talk about, and this video is so long already that we're going to split this into 2 parts. So we hope you'll come back next week when we will continue our panel discussion here from IBHS, talking more about the first 500 and counting episodes of the Carolina Weather Group, our favorite people, the incredible memories, and so much more. Our 500th episode celebration continues, so stay subscribed.